So this is section point 5 about exponents and powers. This is very, very important for Math 110, that you come into it understanding the rules of exponents without any problems, without any questions. So I have a little list here of what the rules are that hopefully looks familiar to you. There's the rule and then an example of what it might look like. When you raise anything to the 0 power, except for 0. 0 to the 0 power is not 1, but anything else to the 0 power is going to be 1. Anything to the first power is whatever you're raising to the first power. When you go to multiply two things that have the same base, you add your exponents. If you're dividing two things with the same base, you subtract your exponents. We did that in section point 4. Raising a power to another power, you multiply them. And if you're raising two things that are multiplied to a power, they each can have their own exponent. If you're dividing and there's an exponent outside, they each can have their own exponent. The -1 power makes 1 over. The -3 power a power makes 1 over, but 1 over x raised to the a power. 1 over n power makes a root. M over n power makes a root, where m is the exponent and n is the type of root. So these are the rules of exponents that you should already know. What I want to try to do is make them a little bit more understandable if you're having trouble with them. So that's what this little table is meant to do. Sorry, just trying to move this for the camera. So this table is supposed to explain why the negative exponents work the way they do and the fractional exponents work the way they do. And this might help you if you struggle with exponents. So if you think about the fact that 4 to the 0 is 1, the reason why 4 to the 0 is 1 can be related to this rule for exponents up here, where if you're dividing, you subtract your exponents. So you could imagine that if you had 4 to the 7th and you were dividing it by 4 to the 7th, that would be 1, right? Anything divided by itself other than 0 is 1. So you could see that that would be 1, but the rule says the other way to do it would be to subtract 4 to the 7 minus 7. Well, that's 4 to the 0. So because anything divided by itself is 1, 4 to the 0 power has to be 1, because in a division problem, it would be like dividing something by itself. But then if we move up 1, the reason why 4 to the 1st is 4 is you could think about it as 4 to the 8th divided by 4 to the 7th. That's what the first exponent means. It's like you had one more 4 factor when you were doing your division, and you end up with 4. Well, what does 4 to the 1/2 mean then? We're somewhere in between. And if we're somewhere in between, then what we're going to do is think about, we don't have one extra factor of 4 that we're dividing. We only have a half of an extra factor of 4 that we're dividing. So the reason why this is the number 2 is we're thinking about factors of 4, and instead of having an extra factor of 4, we only have half of the extra factor of 4. And in the sense of what that means is, since 2 times 2 is 4, we only have a 2. If we think about 4 as our entire factor, we only have part of it. And that's what the half power means. So we would say 2 to the 1/2 times 2 to the 1/2. If we put them together, that would be 2. That's what half of a factor of 2 would look like, the square root. And half of a factor of 4 looks like the number 2. So then if we move to the 3/2 power, right here, that's in between 4 and 4 squared. 4 squared is like having 2 factors of 4. So that's 16. 4 to the 3 halves is like having a factor of 4 and that half a factor, which is 2, and it ends up being 8. It's between 4 and 16, it's the number 8. It's a whole factor of 4 and then that extra half of a factor, and in half of a factor we mean the square root. So we could do the same thing here. 4 times 4 times 4 is 64. That's 4 cubed, but 4 to the 5 halves would be like having a 4 and a 4, and then instead of another 4, we only have 2. We have the square root. And that gives us 32. So as we move forward with positive exponents, we're multiplying extra on. But if it's a fractional exponent, we're not multiplying 4s on all the time. We get that extra half of a factor, which is what the square root is. If we back ourselves up into negative exponents, then we talk about 4 to the negative 1 and 4 to the negative 1/2. Then we want to go back to this idea again. 4 to the negative 1 would be like having not the same number of 4s when we're dividing. We're having one more when we divide. So 7 minus 8 is negative 1. So it would look like this. We had 7 factors of 4 and we divided by 8 factors of 4. And what happens in that situation is 1, 2, 3, 4, 5, 6, 7. 7 4s multiplied, 8 4s. 2, 4, 6, 8. 7 of them are going to divide out, which is what happens when we have the same number. They divide out and we get 1. Well, now we got that extra 1 on the bottom, not the top. And that's why this answer is 1/4. 4 to the negative 1. You have 1 extra factor on the bottom. Well, 4 to the negative 1/2, you have that square root left on the bottom. So instead of being 2, which is the square root of 4, you have 1/2. And 4 to the negative 3, you're going to have 3 halves, sorry. You're going to have this 8 left on the bottom. And 4 to the negative 2, you're going to have this 16 left on the bottom. So you can work your way backward in the table as well. With negative exponents, you always get the extra factors left in the denominator instead of the numerator. So what I'd like you to do is, based on these, I'd like you to just sort of turn the video off a minute and try to simplify what's in the box there. And then I'm going to do the work, and you can take a look and check yourself. But it's better if you try it first instead of watching me do it, just to make sure what you really understand. So I'm going to use the fact that 2 to the 1/2 is the square root of 2, and 50 to the 1/2 is the square root of 50, and I'm going to multiply and get the square root of 100, which is 10. So I'm using this rule here. They both had the same power, and instead of keeping them with their own exponent, I just multiplied them together with that exponent. Here I'm going to use the 6 as that extra exponent. I'm going to use this rule, A times B rule here, and I'm going to take 2 to the 1/2 times 6 and 2 to the 1/3 times 6. So I'm going to use that rule of multiplying, and that's going to give me 2 to the 3rd and 2 to the 2nd, and I'm going to get 2 to the 5th, which I can leave as 2 to the 5th, or I could call it 32. Here I'm going to subtract my exponents. So I have 3 halves and I have 1/2, and when I subtract, I get 5 to the 1st. Here I'm going to distribute through, and I'm going to have x to the 1/2 times x to the 3 halves, and 3 x to the 1/2 and another x to the 1/2. They're both square roots. So I'm going to get x squared when I add these together and get 4/2, and 3x when I add these together and get 1. In this problem, I'm going to subtract my exponents, and I'm going to end up with -1 minus 1/2, which is -3/2, and I can write it as 1 over x to the 3/2. So I pulled them together with one exponent. That's the goal. That's not always the goal in algebra, but that is the goal in calculus. I want to try to pull these two together and only use one exponent, either a -1, which sometimes we'll leave as negative, or you can put it in the denominator like you might feel more comfortable doing. But you don't want two x's in a division problem. And then finally, I'll look at this one as 1 plus x to the 1/2 times 1 plus x to the 3/2, and use the idea from last notes that these are the same base, and so I can actually add the exponents together and call it squared. 1/2 plus 3/2 is 2. So this next section goes back to the idea of what we were doing last time, factoring out. I just wanted you to have some more practice problems with those, factoring out the fractional exponents that we started last time. And so again, I would turn off your video for a minute and try them, and then check your answers with what I'm doing now. So I'm going to compare the exponents, factor out the lowest degree. I'm going to subtract my exponents and say I have no x's, but I need to put a number 1 here, because if I wanted to distribute back, I need to be able to get back to this. So there's a 1 here, and I'm going to leave it there. And then 2/3 minus -1/3 is 1, so 2x. This is -5/3 and x to the -2, because x squared in the denominator. I'm going to factor out the lowest one, which is -2. I'm going to subtract my exponents, so -5/3 minus -6/3 is the way I'm going to think about 2. So I'm going to get x to the 1/3 plus 1. -2 minus -2 means I need to put a 1 here. Factoring out x minus 2 and 2x plus 3. And now I'm going to compare degrees to figure out what degree to factor out. -2/3 and 1/3. 1/2 and -1/2. So when I subtract my exponents, I don't have any x minus 2's. And I have 2x plus 3 to the first power. 1/2 minus -1/2. Plus, sorry, I wrote minus, that's plus. 1/3 minus -2/3.